Honestly, this is probably my favorite problem that we see in the free response. I find these a lot of fun. You're just running through some of the derivatives and integral rules and that kind of stuff, putting it all together. So let's just take a look at the table. Really cool table. So let k of x equal f of g of x. Write an equation for the tangent line to the graph of k at x equals 3. This is the main part. Over here, they're talking about f and g being continuous. We talked about that in the last problem. Just a bunch of jargon, really. And the table above gives us values of the functions, of the derivatives. So a lot of times these words are really what messes with the students on the AP test. You got to learn which ones to read through. Continuity is important because you really can't answer these questions without it. But in the end, you don't want to be stuck on that word continuous because it really doesn't play into the main thing that we're doing. So let's go ahead and take a look at part A. So A is saying that k of x is f of g of x, which is really cool. So we're going to go ahead and write the equation of the tangent line. So tangent line, if you remember, tangent line is y minus y1 equals m times x minus x1. So let's start with the slope. Let's go ahead and figure out what the slope is. So let's do k prime. So k prime of x equals, and we got to do the chain rule, f prime of g of x times g prime of x. Well, we want this at x equals 3, don't we? So I'm going to go ahead and plug a 3 in. So k prime of 3 equals f prime of g of 3 times g prime of 3. So let's start with our g of 3. What's g of 3? Well, g of x and 3 is 6. All right, so f prime of 6 times g prime of 3. So let's look at f prime of 6. F prime of 6. F prime of 6 is 5. And then g prime of 3. G prime of 3 is 2. So my slope is 10. So that's going to go in for m. So what we have from our equation of the tangent line, I'll go ahead and bring this to the right a little bit more. So we have that m is 10, and then also x, we already know our x is 3. That was given to us in green right here in the beginning. So x is 3. All we need to do is figure out what is y1. Well, y1 is going to be k of 3 because we're doing the tangent line to k. Well, k of 3 is going to be f of g of 3. This one's really simple. So g of 3, then go back to our graph. G of 3 is 6. And then f of 6 is 4. So k of 3 is 4. So y minus 4 equals 10 times x minus 3, and there's your answer. So realize that the equation of the tangent line, this is 1 point, and your slope is 2 points. All right, let's go ahead and take a look at part B. Let me just move this over. So part B, I'm going to erase all this highlighting. So this one's just going to use a good old quotient rule. So h of x equals g of x over f of x. So they want us to find h prime of 1. So h prime of x is going to be g prime of x times f of x, derivative of the top times the bottom, minus the top times the derivative of the bottom. Notice they just flip around f and g. We're used to f being the top and g being the bottom, so just be careful with that. Can't just memorize the formula in this case. You got to be thinking which one's the top, which one's the bottom. And this is going to be over the bottom 1 squared, so f of x squared. And then h prime of 1 is going to be g prime of 1 times f of 1 minus g of 1 times f prime of 1 all over f of 1 squared. And then g prime of 1, let's look at our table. So g prime of 1 is 0. F of 1, which really doesn't matter at this point because it's going to, oh wait, I looked at g prime of 2, never mind. G prime of 1 is 8. I need to be careful there. F of 1 is negative 6 minus g of 1 is 2 times f prime of 1 is 3 all over And man, my fraction signs are bad. F of 1, which is negative 6, squared. So there we'll get negative 48 minus 6 over 36, which is negative 54 over 36, which will simplify down to negative 3 over 2. And that's it for that one. Not too bad. Let me move it out of the way, and we're going to take a look at the next question, which is my favorite one on here. And why is it my favorite? Because honestly, this is a really easy question, but for some reason, everyone seems to get these kind of things incorrect. So we're going to go ahead and evaluate from 1 to 3 f double prime of 2x dx. Now what am I going to do? I'm going to try doing the antiderivative. Run it through that fundamental theorem of calculus, but we're going to have to do some chain rule on this. So the chain rule here, we're going to or not chain rule, reverse chain rule, u substitution. So u is going to be 2x, du is going to be, my writing's getting worse and worse, 2 dx. So we get du over 2 equals dx. Substitute this in. I'm going to change the bounds because I like to change the bounds. So there we are. And then we're going to go ahead and do the integral of f double prime. Well, what's the antiderivative of f double prime? Guess what? It's just f prime. So we have f prime of u from 2 to 6 and 1/2 of that. And then we run that through that fundamental theorem. So let me just put equal signs here, just kind of clean that up. So we get 1/2 of f prime of 6 minus 1/2 of f prime of 2. And guess what? So this usually is going to confuse people, but if you just go through the process that you know, try to do the antiderivative here, run it through the fundamental theorem of calculus, guess what? F prime of 6, that's in our table. F prime of 6 is 5. Minus 1/2, f prime of 2 is negative 2. So then we end up with 5 over 2 plus 2 over 2, which is 7 over 2. So something that looked really complicated in the beginning really wasn't far out of your reach. It's not, everything there you have done. And it's actually even easier than the stuff that you've done. So if you run into something like this, don't overthink it. Just, sometimes go for it. And a lot of times it's going to work out.